Hi, everybody. So my name is Jacob Schumi, and what I've decided to do is over the next few videos, I'm going to do kind of an introduction to Mathematica. Now, instead of cramming this all into a classroom setting where students don't have time to ask questions and kind of get behind sometimes, I thought that what I would do is I would break it down into more of a category-based video kind of series here. And over time, you can watch these videos on your own, and you can go back and rewatch them to get assistance as you approach and as you start to work on your Mathematica project as I assigned in class. So in this first video of the series, I'm going to do just kind of an overview of what Mathematica is. We're going to learn about where to download it, how to download it, and kind of learn some of the basic non-calculus stuff that we can see in Mathematica. And then in future videos in this series, we'll learn different things that will help you prepare and help you be successful in the project that you have to complete. So first thing I'm going to do is I'm going to share my screen with you all. So let me do that. All right. And so one of the first things that students will have a question about is, well, how do I get Mathematica? Now, one of the good things is that since you are an MSU student, you do get Mathematica free of charge for being a student at Mississippi State University. So what I want to show you is where to do this at. So I have put a link for this page in your Canvas page, but if you want to go here directly, you can go to the ITS website. So as you can see at the very top left in the search bar, it is its.msstate.edu. And what you will do is, I think the fastest way to get to it is if you go to the software link that is here right at the top, kind of this ribbon banner. And this will show you every program that MSU offers to students. We are going to scroll down to the Mathematica section, click on that. And then what you will see is it has information of university computers. Don't worry about that one. Obviously, y'all are not faculty and staff, so don't worry about that one. But you'll notice that there is a student use link where you can click on this and download Mathematica. Now, down below, this might be helpful for some of y'all. If you are using a Windows computer, which is what I have on my office computer, as you can see, if you want a PDF instructions of how to do this, there is installation instructions right here. For some of y'all who are using a Mac at home, they have installation pages here for Mac. So make sure you use those to guide you in the downloading and installation of Mathematica. So when you click on the student use link, you'll notice that it's going to give you a few legal requirements you have to read through, and you have to agree to those. And then obviously you need to tell Mathematica which operating system you are going to use. Now, 99% of y'all are going to probably be using Windows or Macs, but if you do have a Linux operating system, you can go through the same idea to get it downloaded. You should only be downloading this preferably on one machine, probably your personal laptop or your personal desktop that you have. But if you do have two computers you want to do, you could do that as well. But typically I just kind of stick to one and go with that. Now, at this point, I'm not going to click the button because I've already have Mathematica downloaded, but you would click on Get Software, and between this and the installation instructions over here on the previous page, you can go through the steps of downloading Mathematica. Now, let me minimize this. Once you open Mathematica, now you'll notice that I'm running on version 13.2. I think they're into version 14 now, so no big deal there. As long as you have a version, I think MSU currently is on, I think 14.2, you should get a very updated version of Mathematica. All these versions pretty much do the same thing. So let me show you a couple of things about Mathematica just to kind of get you started. Everything in Mathematica is written in a document folder. So the first time you use this, you need to click on New Document. And I'm going to maximize this just so it's a little bit easier for me to see here. This is what we call a notebook file. So everything in Mathematica is written as a notebook file. You can find everything that you need within here. A couple of things, like I said, just kind of getting you started here is really two major things, I think. Number one is there are some built-in codes in Mathematica that you don't have to know how to code. Instead, there's a built-in palette that will allow you to shortcut some of the code to an extent. So one thing I would recommend you always open and have open while you're working on your project is if you go under the palettes tab at the top and you go down to Other and click on Basic Math Input, This will bring up a palette of some of the more popular built-in codes. For example, square roots, integration. Some of these symbols you may not know. There's a matrix if you're doing linear algebra, but you can look through some of these codes, and some of them you'll use, some of them you will not. Now, below this, you will see some other symbols that are very popular, such as pi, your exponential function, if you're using imaginary numbers for anything, infinities, and so on. And then even below that, you have all of your Greek symbols that are more popularly used in mathematics, such as theta, or some of y'all might be using phi. There's pi again, rho, lambda, but you can look through those and you can use any of those that you want because they're already built in and you don't have to code them separately as we go through these next series of videos. The second thing I would recommend that either you open ahead of time or at least you know where it's at is the help feature. So under the very last button, it says help. If you click on the very first one that says Wolfram documentation, this is essentially like a Google search for Mathematica. If you are trying to explore what you need to do, or if you're not quite sure of any built-in codes that might exist, this is something that you can use. So for example, if I was trying to do, let me think of a calculus idea. If we were trying to find the area under a curve, I would search that, and what you could do is you could try to look through any built-in codes that might help you. Now, since you have made it through Calculus 2, you might remember from Cal 2 that to find the area under a curve, you need to integrate. Now, integrate has a built-in symbol. So if you clicked on this, this is where you're going to need to have internet. It's going to take you to the different ways that you can use the integrate built-in function in Mathematica. So whether it be integrate to give you an indefinite integral, or whether you want to integrate to use a definite integral, y'all probably haven't got to multiple integrals yet, but when the time comes and you get to that course, you can use multiple integration in Mathematica. But these give you different built-in ways to do area under a curve by integration. Not only that, if you scroll down, this Wolfram help also gives you examples of code that you can practice on your own in order to see how it works. So whether it be evaluating an indefinite integral, whether it be computing a definite integral, or visualizing the area under a curve, you can go through this and you can read through different ways of how to do these. Also down here, you got tons of application problems, so there's plenty of examples for you to kind of build upon as you're beginning to learn this Mathematica coding language. So I would recommend you always know where those two things are. Now, the other thing to be aware of as you're working through Mathematica is there's actually two different lines of input that you can do in Mathematica. The first thing you will notice is that there is a horizontal line across the very top that has a plus symbol in the left-hand side. Whenever you see a line like this, this means you are currently in a coding line. So anything that I would type in right now, it's trying to code this. Now, obviously, I just typed in a bunch of gibberish here, but this means you're in a coding line. So now if I were to delete all of this, and then if I were to click back right at the very top, put my plus symbol back in, I am back in a coding line. Now you'll notice over here on the far right, it went ahead and opened what's called a kernel. Now, since I deleted it, it keeps that kernel there. If you ever want to get rid of a kernel that's kind of not necessary, you can always click on that and just hit delete. And that's perfectly fine right there. So now, outside of a coding line, the other line that you might need to use is what's called a plain text line. Now, in the instructions for your project, you'll notice that I mention you need to keep your work organized so that way I can follow along when I'm grading it. To get to a plain text line and to keep your work organized, here's how you do that. You will click on the plus symbol at the very end of your code, and at the very bottom, or not the very bottom, next to the bottom, you'll see the word plain text. If you click on that, you'll notice that your cursor turns vertical and you are now simply in a word processing unit within Mathematica. So if I was trying to organize my project, I would do something like Jacob Schumi, because I'm going to work on the project. And then this is Mathematica project. And so I could click right below that, and you'll notice that I'm back in a coding line. Now let's say I'm ready to work on the first question. Another thing you could do is you could do, okay, new plain text line. Let's do question 1 And then you can just kind of give a brief title of what you're doing. We are going to do a calculus problem. Now, you would be more specific than that, but I don't have the project written or in front of me right now. So just kind of give a brief idea of what your question you're answering is. And then once you're ready to start coding, you can click right below, and therefore you're back in a coding line. So anytime you just want to type something out, whether it be an explanation or whether it be an introduction to something, you can just do that in a plain text line. Now, the very first thing we want to do, we're going to do our first little bit of coding here, is we want to look at how do you do functions. Because within this class, a lot of things you are going to do are going to be function based. So the first thing you want to know how to do is how do you define a function? So we're going to define a few functions here. So probably, let's say 3 of them just to kind of give you some practice. Anytime you want to define a function, here's how you'll do it. Let's call it f of x. Now, in your mind, you would probably want to type it like this, f of x, because that's the way Mathematica, that's the way maybe you think about when you type on a word processor. But you'll notice that in the kind of the AI, the built-in stuff, Mathematica is telling you that something's not right. That's because in coding, parentheses don't help you define anything. Parentheses are just meant to be grouping operators, so you don't want to use parentheses unless you're trying to group something together. Instead, what we want to do is we would like to do a bracket, and we're going to, for the first time you define something, you want to put an underscore right after the x the first time you define a function. So in this case, we're going to do f of x with an underscore, and when I put the equal sign right after that, you'll notice that your x turns green, which means Mathematica is ready to accept whatever function you want to call it. So let's do a really easy one. Let's just do x squared plus 1. So you can either use the built-in exponents over on the right, or what you can just do is use very basic syntax, and we can call it x raised to the second plus 1. Now, I want Mathematica to remember this, so the next thing I'm going to do is right after I'm done typing my function out, you are going to hold the shift button and hit enter at the same time. So I'm going to hold my shift button down, and I'm going to hit enter. And you'll notice Mathematica has now accepted this first line of code, and it gives you the output. So it is confirming that f of x is now called x squared plus 1. Let's do another one. Let's do g of x. So first time doing g of x, remember the first time you do it, you have to do an underscore. So g of x equals, there's the green. Let's do a square root function. So we're going to do the square root, and I'm just going to use the built-in palette over here on the right. And let's do x minus 3, something really easy. All right, I'm going to click outside the square root, and once again, I want to input this, so shift, enter, and there's your g of x. Now, along with that, you want to make sure that you have some other built-in functions. So there's some very popular built-in functions you might use. For example, trigonometry. Let's do h of x now. So h of x equals, when it comes to trig functions, if you ever use those, you want to make sure that trig functions have to be capitalized. So let's say you were going to do sine of 2x. If you were to do lowercase sin, you will notice that your sign is currently blue because Mathematica does not know what that is. But if I were to change the first letter to be capitalized, you'll notice that it makes it black because Mathematica now knows what this function is. So remember, you can't use parentheses, so we're going to do sine of, and I'll just type in 2x, close my bracket, and then we'll enter that one. Now, trigonometry is the most popular, probably built-in function you'll use when defining functions. Just remember, any of the trig functions you use, sine, cosine, tangent, etc., the first letter needs to be capitalized. The other 2 built-in functions that you might use most often are exponential functions and natural log functions. So let's start with exponential. Let's do our next one. Let's go to a of x just to be different. So if I want to define a of x, let's say I wanted to do e raised to the 3x. So 2 ways you can do this. One thing you can do is you can use the built-in e over here on your palette and just do e raised to the 3x. So we could do e raised to the, now you'll notice here, I'm going to use parentheses because I want to group that 3x together. Now, if you want to keep it similar, you can also use the bracket here, not a big deal, but that's one way you can do e to the 3x. I'll be honest, that's not the way I usually do exponential functions later on in these videos that you'll see. So what I like to do, instead of using the built-in palette, I actually just use the built-in code, which is capital E with an XP. This is the same thing as that E there. And that way, it just looks a little bit more clean to me. So if I wanted to do e to the 3x, I would do capital E AX XP, bracket 3x, close bracket, and then enter this. And you'll notice there's that e raised to the 3x. Now one more, just to kind of make sure you see this one. Let's do b of x, natural log. Now what most people will think is you are going to do ln, but you'll notice it's blue. Mathematica doesn't know what ln is. So maybe you think, oh, it's lowercase ln. No, Mathematica still doesn't know what that is. This is probably the weirdest one and why I'm saving it for last. When you do a natural log function, you're actually going to write it as capital LOG. Since natural logs are a lot more popular than the rest of the logarithms in mathematics, it's the one that's built into Mathematica. So when you do log of, and I'm going to just do of x to make this one easy, that is the exact same thing as a natural log function. So whenever you see a natural log on your project, you'll do it as log of whatever the inside may be. And then I will input that. So whether it's just directly typing, whether it's using something in the palette like a square root, or whether it's using one of the built-in codes, this is how you define a function. Now from there, now that I have all 5 of these functions defined, the next thing you can easily do is you can evaluate any of them. So let's say I wanted to plug the number 5 into a few of these. Now that I've defined everything, if you want to define something like f of 5, you can simply just type in f of 5. And Mathematica will evaluate whatever function you called f of x at the number you're asking it to. So kind of quick mental math. If you plug 5 into that first function, 5 squared is 25, 25 plus 1 is 26. Mathematica does that for you. If you do g of 5, well, that would be the square root of 5 minus 3, which is the square root of 2. And you'll notice that Mathematica always defaults to an exact answer. Now, there will be times in this project where you may be asked to give an approximate answer. Here's the next good thing you can do. If Mathematica spits out an exact answer for you, it's okay. It's probably still correct. But if the instructions on your project on a certain problem say, give the answer in decimals, all you will do is on the immediate next line of code, there is a built-in code of capital N of the percent symbol. This capital N in Mathematica means we want a numeric approximation, and the percent symbol says pull the last line of output that you have. So this is going to ask Mathematica to take a numeric approximation of the square root of 2, which would be about 1.41421. And so you can do that for any of the functions on there. Now, as some of y'all know, when it comes to trig, you might be plugging in angles. So let's do h of, and I'm going to go over here to my built-in code, and I'm going to do pi over 3. So let's plug pi over 3 into h of x, and that would give you an answer of the square root of 3 over 2. And so that's all you have to do to evaluate functions. Once you have the function built in and coded, it's as simple as just telling it what number to plug in. All right, the next thing we want to do is we want to look at how to plot a function. So we're going to plot a couple of these just for practice. So here comes your next built-in codes. And here's one of the greatest, I think, greatest updates that Mathematica did for students. It takes a little bit of the coding out of the way for you. So if we want to plot some functions in Mathematica, you would say, okay, I want to plot something. Now, since this is a built-in code, we're going to use a capital P, L-O-T, and you'll notice that Mathematica is trying to guess what built-in code you are using. So I want to plot something. Okay, so let's try that. If I click on plot, and if you click on this double down arrow right below it, this will give you a few different ways that Mathematica can use plot. And all you need to do is read the description below each one and then pick which one you think is best. For example, this first one says it generates a plot of f as a function of x from some min value to some max. Perfect. I'm going to click on that one. And what Mathematica does is it gives you the shell of the code that you need to use. So this is saying, okay, all these yellow spots I got to fill in. You need to tell Mathematica which function you want to graph. So let's just graph the first one. Let's call f of x. This is asking you, what is your variable? That is x. Then what do you want the min and max to be of your x value? So let's just say we want to go from -5 to 5. Since we use kind of a little bit of a shortcut there, all you have to do is fill in your yellow boxes appropriately and then go to the end and hit Shift Enter. And you'll notice that Mathematica graphs it for you. Now, if you graph a function and you realize that the interval that you gave it just is not appropriate for whatever you're working on, go back and fix it. One of the other user-friendly ideas of Mathematica is, let's say I wanted to go from -2 to 2 instead. Perfect. All you got to do is go to the previous code and change it, and just make sure you re-enter the code, and you'll see that is going to be x from -2 to 2. And so there you go. Right? Now, let's say that you plotted the completely wrong function. If you want to replot it again, you can type all the code out again, or if you meant to plot, let's say, a of x, you can simply just change the x to a. Let's say we meant to go from -3 to 3. I'm just changing a few things here for you. And then we plot it, and there you go. There is your exponential function. So it will graph the function for you as you do this. All right? And so you can play around with this, change your function, change your numbers, but that is how you will plot one function. All right? The other thing you may have to do is, what if you need to plot more than one of these at the same time? Perfect. To do this, though, I'm going to come down and do a different line of code just to help you out. I'm going to go back to my plot. I'm going to click on plot and my double down arrow. And you'll notice that on the second tab, it says plot several functions. Perfect. Let's click on that one. You can plot as many functions as you want at the same time over a common interval. So let's say we want to plot 3 functions. Let's say you want to plot f of x. You want to plot g of x, and let's say you want to plot b of x. X is still your variable, and let's just go from 0 to 4 this time. And so what Mathematica should do is it's going to plot all 3 of those functions that you defined earlier on the same graph. And there you go. Now you can dictate, now it's not going to label them for you, but you can figure out which graph is which. So it looks like this blue graph is going to be your f of x. That's the quadratic function. The square root, which is g of x, is over here in orange. And then this green graph is your natural log function, which is shown there. And so you can plot as many functions as you need. If you wanted to plot one more, let's say I wanted to add a of x in. Just go up to the function list, add a comma, and throw in the extra function. And just regraph it, and it throws it on there. Now, one thing to be careful about is that if you start graphing too many functions and they start spreading out from each other, the graph's not going to be very clean when it comes to you actually graphing this. So just be careful on that regard, but that's the way you can plot as many functions as you want. All right, so now that we've gone over plotting basic functions, I got a couple more things to cover in this first video of the series. The next thing is a second built-in function that we call solve. So one reason that we like to use Mathematica is that some things are very difficult to solve by hand. So we're going to have Mathematica do it for us instead. So if you use the built-in function solve, we'll just call this capital S OLVE and click on that. You'll notice that there's not many options here. And honestly, for y'all, I typically stick with the first one. You can use the second one if you want to mess around with that, but the first one usually will get the job done. So if I click on that, here, you want to tell Mathematica what equation you would like to solve. So I went ahead and made some up here that I know work out. So let's do x squared minus 3x minus 4. Now I want to set this equal to 0. One thing, here's one of the biggest probably issues students have early on in Mathematica. if you use an equal sign inside of a built-in code, so we're inside of a solve function, one equals will not be good enough. You will have to put a second equals and then whatever number you're trying to set it equal to. If you're outside of a built-in code, so if I scroll back up really quick, you'll notice that these equal signs up here were outside of a code. I only used one of them. But when you're inside of a code like solve or whatever else you may use, make sure you use a double equals. And then over here, just tell Mathematica what variable you're looking to solve for. Let's call that x, all right? And then we are going to shift enter, and you'll see Mathematica solves it directly. X approaches -1 and x approaches 4. Those are your two answers to this equation. Now, as you probably know, not everything works out nicely in math. So I'm going to change this just a little bit. So instead of using this equation, let me change a couple of numbers to show you what happens. We're going to do minus 4x, and let's make this minus 7. So let's change some numbers. If you were to solve this one, you'll notice that Mathematica will solve any equation that is solvable within this code. In this case, this one probably does not factor very nicely. And as you can see, your two answers are 2 minus the square root of 11 and 2 plus the square root of 11. So you can use this for any polynomial equations you are trying to solve. Now, we can also use this for trig, and trig answers look a little bit different, so I do want to do a couple of those for you. So let's do a separate solve function. So solve, and first one again. So let's do a very simple solve trig function. I want to figure out where does sine of x, remember double equals, equal cosine of x. And I'm going to put my variable of x in there again. Now, what you might know in math and trig is that cosine and sine are equal to each other in quadrant 1 and in quadrant 3. But when you ask Mathematica to solve this, it's going to give you a little bit of a weird answer in this case. You'll notice that the two answers that it gave us is negative 3 pi over 4 plus 2 pi times a constant, and then pi over 4 plus 2 pi times a constant. The reason it does it this way is because, remember, in trigonometry, every time you add 2 pi or subtract 2 pi, you're still getting an equivalent location and thus an equivalent answer. So don't be panicked by this plus 2 pi c that you will get on all trig equations. You want to focus on the angle that's in the front. So if I were solving this for two unique answers, one of them would be negative 3 pi over 4, and the other one would be at 1 pi over 4. Now, you can also do as complicated of trig functions as solvable. So let me delete this, and let's change the equation just a little bit. Let's do sine of x is double equal to 2 minus 2 times sine of x. Now, when I solve this equation for x, you'll notice that it actually wasn't able to solve it exactly. It gave me the answer as pi minus the arc sine of 2/3 plus 2 pi, and then arc sine of positive 2/3 plus 2 pi. If you don't know what that is, remember we have a way of approximating this. You can do capital N of percent, and we can do the exact same answers. Now, once again, remember with these trig problems, this plus 2 pi is just taking care of the cyclical action that's happening in trigonometry. You're focused on the first part. So if I was looking for an approximate answer here, my answer would be, the 2.41186 and the 0.729728. The 2 pi is the 6.28 part. You wouldn't worry about that as far as your answers go. Now, do note that in Mathematica, all right, these are radian answers. These are not degrees. So if you want to change any of these into degrees, you would have to do the conversion from trigonometry by multiplying by 180 over pi. But most answers in radians will suffice in this class. The last thing I want to show you in kind of this intro video without any calculus built in yet is what happens when you're done working whatever problem you're doing. Obviously, in these problems, we have defined a bunch of things here, especially back towards the top. Remember earlier, I defined an f of x function, a g of x function, h of x, a of x, b of x. When you're done, you might want to use some of those letters again on a future problem. So the last thing I would always do before you move on to question 2 or the next question is you want to clear those variables. So in Mathematica, we have a nice little clear function, open bracket, and you're just going to list every letter of a function that you want to clear. Now you'll notice that I'm not going to type f of x. That's not necessary. In Mathematica, since x is your variable, you just want to clear the actual function. So that would be f, g, h, a, b. And you'll notice that all of them are currently in black text. If you put a letter that's not a built-in, not a defined function, I should say, let's say we put c. You notice that C is blue because Mathematica doesn't know what lowercase c is because we haven't used that letter for anything. So that's a way you can keep track of. Now, nothing's going to happen here except for watch what happens to the color of all these variables. They're black because Mathematica knows what they are. When you enter this, so shift enter, they all turn blue. And at this point, Mathematica no longer knows what f of 2 is because you have cleared the functions that you defined earlier. So keep in mind, if you clear a function too early, you'll have to go back into your code and re-enter everything before you can add anything new. So I would make sure you are completely done with your problem, you have the answer that you are looking for, and then I would clear whatever variables you've already defined. So that is the end of this first video that I'm going to do in this series. In the next video, we're going to start moving into some of the calculus topics. In the next video, we're going to focus more on the Cal 1 and 2 material. So how do you do differentiation? How do you do integration? That way we are completely prepared for the Cal 3 material, which is what will show up on your project. See you in the next video.